All right, guys, we are going to do the Alka-Seltzer Lab. This is going to look at both solid solubility and gas solubility. So we're starting with a temperature treatment. We have water in 3 different temperatures. We have a hot water, we have a room temperature water, and then we have an ice water. The water has been treated with universal indicator. The universal indicator tells us the pH of the water based on the color of the indicator. So right now, as you can see, it's a pretty dark green. I would put it closest to here. So right now our starting pH is an 8. So we're starting with this dark kind of turquoisey green, and that's a pH of 8. So you'll want to write that down. Our room temperature water is at 28.6 degrees Celsius. You'll want to write that down, 28.6 degrees. Our cold temperature water, let's get these where we can see them. Our cold temperature water is at, just a second, it's still dropping. Looks like 15.4 degrees Celsius. Our hot water treatment the hot water treatment is at 70, still going up, 78.7. So now what we're going to do is we're going to put 1 gram of Alka-Seltzer in each one of these. I will try and do these as simultaneously as possible. You're going to want to start the time as soon as I put them in, okay? And then we're going to time how long it takes for these to go. So make sure you make note on the video of the time, or start your timer on your phone right now and start your timer. Okay. You can see the hot water fizz a lot faster. Then you've got a lot of fizz here. This one's fizzing a little bit slower. Hot water is done. That solid tablet is all dissolved. Room temperature is slowing down. Not quite done yet. Cold water is still going. Room temperature is done. Cold water is still going. Cold water is still going. And cold water is done. So, mark your times for how long it took each one to dissolve the solid tablet. Okay, now what I want you to look at is we need to determine which ones are saturated and which ones are unsaturated. Remember, a saturated solution dissolves as much as it possibly can. Okay, and a lot of times that means we have some of the solid left over. So if you look at the hot water treatment, you see no solid left over. If you look at the room temperature, you can see along the edges here, it's up against the rim of the glass. You can really see it right there. There's still some solid left over. So since there's definitely some solid left over, this is a saturated solution. The cold one, we can also see lots of solid. The solid's not always at the bottom. In this case, the solid is less dense than the water, so that's why it's floating up at the top. But you can definitely see lots of that solid floating in there. So we've got a saturated solution for the room temperature, a saturated solution for the cold water. The hot water, we are going to assume, we're assuming that this is an unsaturated solution. One, because it went so quickly, and two, because there is no solid floating at the top. Now we need to look at the colors. Okay, so based on the pH indicator, this looks like this lighter green. So we're gonna call that a pH of 7. This one looks more of a yellowy color, so we're gonna call that a pH of 6. This one looks closer to the orange color. It looks partway in between, but we're gonna call it the orange color, and that's a pH of 5. What the pH is telling us is how much carbon dioxide is still in the solution. So the bubbles you were seeing, that was the carbon dioxide in the Alka-Seltzer. Carbon dioxide, when it mixes with water, makes an acid. It makes carbonic acid. That's what we get in our carbonated beverages. That's what gives them the fizz. So what we're seeing is that this has a lower pH. This means that this has more acid in it than this does. So that means this has more carbon dioxide gas in it because it made more of the acid. This is a very simplified explanation. Very simplified. So this one has more carbon dioxide dissolved in it. Then this one has the next most carbon dioxide dissolved in it. And then this has the least amount of carbon dioxide dissolved in it because it has the highest pH. So most gas, least gas, but most solid, least solid. Okay, so gases like it cold. They also like lots of pressure. That's why our carbonated beverage containers are under pressure. When we open them, they make that hissing sound. Okay, solids like it warm, gases like it cold. So they have different temperature preferences. That's why on a solubility curve, all of the solids have a positive sloping line and the gases have a negative sloping line. Okay, so make sure you have all of your data written down for your Alka-Seltzer Lab, and then you'll want to get that turned in by the due date.